In this video, we're going to learn about section 18.5, predicting the spontaneity of reactions under conditions other than standard state. This is important because, as we learned in previous chapters in the semester, reactions are very rarely under standard state conditions. For example, if you're interested in determining if glucose will spontaneously become oxidized in your body, the glucose will not be at 1 molar, and the oxygen will also not be at 1 molar. So determining the spontaneity of reactions under conditions other than standard state is very important in all types of applications, including biology. Here's the expression that we wrote down from section 18.4, and it relates E naught cell to delta G naught. So delta G under standard conditions and E cell under standard conditions. You'll notice from the expression that if you get a positive value of E naught cell, then you will actually get a negative delta G, because E naught cell is multiplied by negative NFE. What that means is that if the E cell voltage is a positive number, delta G is negative, and therefore the redox reaction is spontaneous. So a positive cell voltage means a spontaneous redox reaction under standard conditions. So now we want an expression to determine if the redox reaction is spontaneous under non-standard conditions. So what we're going to start with is our expression for delta G under non-standard conditions. So here's our expression relating delta G not under standard conditions to delta G under standard conditions. And the way we adjust delta G under standard conditions to be non-standard is this adjustment factor, which requires the use of Q, the reaction quotient. So you've seen this expression before, and hopefully, as you can see, the way I've written these two expressions, that you could substitute E cell in for the delta G values written below. So I'll do that and show you the end result, which is this. Here we've rewritten the expression substituting in negative NFE cell, and you'll notice that we have NFE cell under non-standard conditions and also NFE cell under standard conditions. Notice I did put the naught here to substitute for delta G naught. So next I'll do a little bit of algebra and rearrange and change the natural log into a log to give you the final expression that you actually need to answer homework problems. So the final result is what we call the Nernst equation, and it simply relates E cell, that's the E cell not under standard conditions, to some E cell that you could calculate looking up the values in the textbook or table of standard reduction potentials, and then we adjust it using some adjustment factor that relates or requires calculating Q. Now Q, again, is the reaction quotient, so it's concentration of products over reactants. And the other thing to note about this expression is that, again, it's log base 10. We've changed the log going from this expression to that expression. So in order to answer ALEKS and homework and exam questions, all you really need to know is this final Nernst equation. The point of this video was just to point out that even though this equation looks formidable, it's actually the same thing as this expression up here, this delta G expression that you already used before in previous chapters.